Alright folks, today is the last section in Chapter 13. We're going to talk about that last section on your blue note card, the half-angle formulas. Okay, so I brought them up here. They're kind of messy, and they're messy for a couple reasons. One, we've got this plus or minus. We have to worry about signs, just like we did with the Pythagorean theorem. We've got a square root that's happening, and normally that's not really a whole big problem, but there's a fraction inside. We know if we have like just the square root of 1/2, we have to end up rationalizing that, so that's going to be a possibility today. And then also, cosine is adjacent over hypotenuse, so there's a fraction involved, which means we're going to have to get common denominator to be able to actually simplify that inside the parentheses part. Okay, we're going to start out just like last time with developing these formulas from a formula that we've already talked about. That formula is going to be the double angle formula. What I want you to do is grab your note card for me and take a look at the cosine 2 theta formulas. There are 3 of them, remember. What we're going to do is use this to talk about the half angle. Okay, and how this is going to work is because this says sine of the half angle first, we're going to use the cosine double angle that has sine involved. Okay, so that looks like cosine 2 theta equals 1 minus 2 sine squared theta. Okay, and right now this doesn't look even a little bit relevant because we don't have alpha. We definitely don't have alpha over 2. Okay, but that's the substitution we're going to make next. We're going to let this theta that we see in both places be changed to alpha over 2. And that's allowed because when we're talking about theta, it's just a placeholder for some number. We can put a half of some value just as easily. Okay, so we're plugging in here. Now we've got 2 times alpha over 2 instead of that 2 theta. And then on this side, same thing. Instead of theta, we're putting that alpha over 2. And now we actually see the half angle pop up with sine like we were talking about. Okay, but we're seeing it not by itself. So that's our next step, is we're going to move stuff around to try to get this alpha over 2 with the sine all by itself. Okay, so first thing I want you to notice is those 2's cancel out, so that's nice for us. Okay, but then we still have to manipulate this equation. Right? Order of operations says we have to add or subtract first, so we're going to write our cosine alpha, and we're subtracting over that 1. Okay, then we've got this negative 2. It's really negative 2 times sine, so we got to divide it over. That's gone. And last step, to get rid of a square, we do the square root on both sides. So we've got the square root of cosine alpha minus 1 all over negative 2. And then the sine squared, I'm just going to bring it down here. We took the square root of as well. And those cancel out. So sine of our alpha over 2. When we take the square root of something, we've got a plus or minus, and then we've got this right here. Okay. There's nothing wrong with this form for a formula because it's not our final answer. We're going to substitute stuff in anyway. Okay, but it does look a little different from that formula I just showed you on the note card because they wrote the 1/2 to the side. Okay, this factored out. You can factor out that 2, but it's on the bottom. So if we're factoring out the 2, there's still a negative here. So that means this cosine alpha really becomes negative when we divide by that. And then same thing, this negative 1 over a negative is positive. And they just rearranged it so that the positive 1 came first. Okay, so that's equivalent. Now the reason I did this for you on your note card because, like I said, this version isn't bad. It's just we're going to go put numbers in here, and remember cosine is a ratio. We've been trying to avoid fractions inside of other fractions. Okay, so I just took care of that for you. We'll use this version. We're going to do that same substitution over here. We're still using cosine double angle, but this time we're going to use the one that only involves cosine. So it's 2 cosine squared minus 1. Still going to change those to alpha over 2 so we get what we need to show up actually to show up. Oops. And we're trying to get stuff by itself again. Okay, so our 2's cancel out just like last time. cosine alpha. We're adding the 1 over this time, dividing by 2. But that's still cosine squared. So just like on the last one, we got to take that square root on both sides. Over here, that cancels, leaving us just with that cosine alpha over 2. And anytime we take the square root of something, it's plus or minus. And then this cosine alpha plus 1 all over 2. Your note card says this, the 1/2 factored out. And they did rearrange this 1 plus cosine alpha. Nothing wrong with the order as written. It's just consistency between the formulas to have the 1 come first on both of them. Okay, I'm not going to make you memorize the formulas, so this, how you had it written, was just fine. Okay, we're going to use this version just because of that fraction thing. Alright, so let's go ahead and practice. Okay, if we're looking at these problems, you'll notice we're asked about sine or cosine, and then they plop in some angle. In fact, half of your test is going to look like, in terms of like the formulas that we've been dealing with, half of them it's going to be using these formulas either for questions like this or the A, B, C, D, E problems, okay? And for these ones, when they give you a number, we have 3 options. Okay, we can draw a picture. Okay, that's if we have a special triangle, 30, 60, 45, or any of the multiples of those. Okay, option 2, if we can't draw a picture because it doesn't end up being a nice triangle, then we're going to split it. So we're going to do sine of something plus or minus something else into nice triangles. We take out a 45 and say what's left. And then option 3, if that doesn't work, which we've never seen happen yet, last step is use a half angle formula. Alright, so on this one, it's definitely weird because we've got this 0.5 and we've never seen half of it before. Okay, but drawing a picture is not going to work because we don't have a special triangle that ends in 0.5. We've got one that ends in 5, but not 0.5. Sum is going to work the same way. I could pull out 45 here, but I'm still going to have a 0.5 over here, which is not a special triangle. It won't work. So we're stuck using our half angle formula. Okay, it's the last resort. You're only using it for these 0.5 type problems. So here's how it works. First thing we're going to do is write our formula. This is sine, and this is our half angle. Okay, so we've got sine of alpha over 2 plus or minus. This is from the note card. And we're writing this to get used to what we need to find, what we need to look for to be able to fill out our formula. And this is the whole thing here. We need cosine of alpha. That's the only thing that we plug in. Well, they didn't give us alpha. They gave us alpha over 2. And they also didn't give us cosine. They dealt with sine. So what we're going to do is first decide, well, what is alpha? Okay, so if half of an angle is 67.5, I'm saying that this is half of a special triangle that we should know. Okay, so we're just going to double it to get to the whole angle. Okay, 67.5, when you double it, is 135. And we want to find the cosine of that, because that's what our formula tells us. Okay, that's something you can just throw in your calculator. Okay, I'm going to do it here, just to show you what this number looks like, because we have to be able to recognize it if we're using the calculator method. This decimal, remember, the 0.707 is the square root of 2 over 2. But also, remember, if it's a 45 triangle, if it ends in 5, it has to be the square root of 2 over 2. You just have to decide whether it's positive or negative. Okay, so your calculator can help with that. And now that we have the one thing we need to plug in, we actually go to plug it in. Okay, but when we're looking at our formula, the first thing we see is plus or minus. That comes from this angle up here. This angle is in quadrant 1, which means everything is positive. Okay, so sine would be positive in quadrant 1. Then we're filling out the 1/2. 1 minus this ratio. And we know when we have a double negative, it switches to plus. Okay, so I know a lot of times when we see parentheses, you'll want to distribute, but this I'm going to tell you is easier to do the parentheses first. Okay, so how that looks is we've got this 1 plus a fraction, and in order for us to add fractions, we need a common denominator. So I'm going to leave the 1/2, and I'm going to think about my common denominator. Okay, between the number 1 and something over 2, the common denominator is 2 itself. Okay, so we had to change this 1 to 2 over 2 so that it shares that denominator of 2. Okay, once we have the common denominator, the top, you just go straight over. 2, match the sign, square root of 2. Then we can go ahead and multiply straight across. So I've got 2 plus the square root of 2, because 1 times anything is the anything, and 2 times 2 is 4, which is some good news for us. Okay, when we think about fractions underneath square roots, I talked about this briefly, we take the square root of the top and the square root of the bottom, and we simplify. If we're left with a square root in the denominator, we have to fix it. Okay, for this one, when we take the square root of the top, it literally looks like the square root of 2 plus square root of 2. So double radical happens. It's weird, but it's not uncommon for these. And then we've got the square root of 4, which is a nice, perfect square that simplifies. So the final answer here, we're saying that sine of 67.5 degrees is the same thing as a positive square root of 2 plus the square root of 2 all over 2. And because this is something we can put in our calculator to check it, we're going to. Alright, starting out with your sine 65, or 67.5. And we're comparing that to the big, ugly thing we got here. So square root, 2 plus the square root, again, 2. Hit enter, then divide by 2, and those match perfectly. Okay, next one, it's in radians, but hopefully you recognize that pi over 8 is not something we can draw a picture for. That'd be pi over 2, pi over 4, pi over 3, pi over 6. Those are the only denominators we've seen so far. Okay, so it's not option 1 for sure. Option 2, we'd want to split it up, but we want to be in degrees for that to happen. Okay, just a reminder, when you see pi, you can sub it with 180, and 180 divided by 8. Okay, if you don't know, throw it in your calculator. 22.5. Okay, just changing that. And so because it ends in half, we can't use splitting it up. We have to use the half angle formula. Alright, this is alpha over 2. We need to find alpha by doubling it. So that's 45. Okay, we're doing that because if we're writing down cosine of alpha over 2, our formula says that we need to take 1/2 times 1 plus the cosine of alpha, and we needed to find alpha for that to work. So cosine 45 is going to go in there. That is the square root of 2 over 2 from our sum or difference things, but you can always type it in your calculator. And then we're deciding the sine next. Remember, that comes from the angle we were given. That's quadrant 1 again. Cosine is positive in quadrant 1. So 1/2, 1 plus our ratio would look like 1 plus the square root of 2 over 2. And we're going inside first for these ones. Okay, so bring down your 1/2, and the common denominator between these would be our 2. Same process as before. The number 1, you're just going to write as 2 over 2, so that we can add straight across. So 2 plus the square root of 2, and then multiplying straight across, we have 2 plus the square root of 2. On the bottom we have 4. And a lot of times I'll just skip to the square root of 4 is 2. Okay, but please write as many steps as you need to on these. Okay, so you can leave it underneath. Do the square root of the top over the square root of the bottom, and then simplify if you need to. Okay? This is cosine of the pi over 8, or the 22.5. I'm going to use this version because my mode is in degrees for the check. So cosine 22.5, same decimal as last time, which means this ratio should look identical to last time, and it does. Okay, so final answer, you can always check in your calculator for these ones. Okay, that was half of it. The other half, remember, is your A, B, C, and now we're going to talk about part D and part E. Okay, before we put it all together, though, we're going to practice with how this will look. This part should look very similar to what we did with A, B, and C the last time. They used alpha instead of theta. It's equivalent if we do theta, okay, so we'll just think of it that way. And we're starting, when we see this, by drawing a picture. Okay, so 90 to 180 is right here, and 4/5 is a special triangle, but if you don't know that, you can sure do Pythagorean theorem. 25 minus 16 is 9. Remember, it's plus or minus 3, and we decide based on where it is. So we're on the left, it's negative. Alright, well we did that in part A to find cosine because cosine wasn't given to us. So cosine theta on this triangle is negative 3/5. Now why we need it here is because, again, we're practicing with the half angle, and both half angle formulas use cosine of alpha or cosine theta. Alright, so we're writing our formula down. Cosine alpha over 2, this is coming straight from your note card. And we're going to sub in as we go. Positive or negative comes from the angle. We weren't given the angle this time, so this one's going to look a little bit different. We were given up here that theta was between 90 and 180, but we care about half of that. So we're going to go get the range for the half values. So that'd be between 45 degrees and 90 degrees. Okay, so that's quadrant 1 again. Okay, quadrant 1 is positive for cosine. Okay, then we're filling in 1 plus our cosine value we found was negative 3/5. And this one, because there's not a square root there, it's actually calculator friendly. If you want to do the 5 over 5 and do it the same way as last time so you get practice when you can't use your calculator, feel free. Okay, 5 minus 3 is 2 over 5. Those 2's go away. 1/5. Okay, but you are always welcome when there is no square root symbol to throw it in your calculator. So we can't put the big square root on there, but we could put the rest. It'd look like 1 divided by 2, parentheses, 1 plus a negative 3/5. And then change it to a fraction to get that 1/5 that goes underneath. Okay, completely up to you there. From there, square root of the top, square root of the bottom, just like we have been doing. Square root of 1 is 1. Square root of 5 stays. And so we have to rationalize this one. Okay, we're doing it, trying to get a perfect square on the bottom. We can multiply it by itself. And we end up with our half angle for this one being a positive square root of 5 over 5. Okay. For these ones, because we weren't given the actual angle, you can't check it without using inverse and a lot of other extra steps. Okay, just double check your signs here and the signs from your formula, and you should be good on these ones. Alright, next one is similar. We're going to draw a picture first. They give us 180 to 270 on this one. Okay, pause the video, go fill that out for me real quick. This one gives you negative 3 and 4 is here. 16 minus 9 is 7. Okay, and we do go to the left, so it's negative. From there, our cosine on this triangle, theta or alpha, it doesn't matter, is negative square root of 7 over 4. So that's going to go in our formula as we work through here. Again, we're finding cosine of the half angle. So I'm just writing down the formula. You don't have to write down the formula. It's just nice because it reminds you of the steps you need to take. So in this case, if you didn't remember you had to draw the triangle to get cosine, you would know at this point because you don't have cosine alpha given to you. You'd have to go find it. Alright, so we're going to find the sine first. Remember, you just split all of these in 2 since we weren't given the number. So that's 90 to 180. Oh, excuse me, sorry, 90 to 135, which is quadrant 2. Cosine in quadrant 2, going to the left, is negative. So we're starting out with a negative. 1/2 stays. In your parentheses, we have 1 plus cosine ratio was this fraction. And this one we're not allowed to put in our calculator because of this square root symbol here. Won't work. So we got to get a common denominator first. Remember, inside fractions first, or inside the parentheses. 1/2 comes down. Our common denominator here would have to be 4. Start out with that. Okay, we are changing the number 1 to 4 over 4. There's our common denominator, and now we can just go straight across. 4 plus a negative is just 4 minus that square root of 7. Okay. Next step, same thing we've been doing. We're multiplying straight across. 4 minus the square root of 7 all over 8. Now I'm going to pause and remind you of a couple things here. We're not going to reduce, 1, because that gets us right back to where we started. Okay? And 2, we cannot take the square root of 4 because order of operations tells us we're subtracting first. Okay, so you are not breaking down anything inside where there are 2 terms. It's not allowed. Okay, what we are going to think about breaking down is the bottom. We've got the square root of 8 on the bottom, and it doesn't simplify. It's not a perfect square like it was. Okay, but also the square root of 8 is something that we haven't seen on the bottom alone ever. I'm going to pause and talk about this for a minute. Okay, so if we think about some rational numbers that we're used to seeing, 1 over square root of 2 rationalizes square root of 2 over 2. 1 over square root of 3 rationalizes square root of 3 over 3. 1 over square root of 5, same thing, square root of 5 over 5. We can do this as long as the number on the bottom is not something that breaks down. But as soon as we get to something like the square root of 8, that doesn't work because normally it's actually 2 square roots of 2. You're not going to see 2 square roots of 2 show up in problems like these. We're going to see the square root of 8. So what we have to do is a little bit different. Okay, so I'm going to talk about this from the beginning here, just with this first example. This one ends up being the square root of 2 over 2 because we multiply by itself. You were told to do this because a square root and a square root cancel each other out. But what's really happening here is we've got the square root of 2 over the square root of 4. We're picking a number to multiply by so that the result is a perfect square. And one way to do that is just by multiplying by itself. But it's not the only way. And in fact, it's not the best way always. So here, for example, we don't want to multiply by 8 because that's going to cause the square root of 8 over 8, and the square root of 8 is something that we have to break down. We don't want to add extra steps for ourselves. Okay, instead, we're going to multiply by a number that gets us to a perfect square. So 8 does, but so does 2, and we want to use the smallest one. 8 times 2 is the square root of 16, which is better because now I have the square root of 2 over 4 without 2 extra steps where I have to break this down and then reduce 2 over 8 to 4. Okay, so we're multiplying by something to get to a perfect square. With that in mind, we've got an 8 here. We're going to have to multiply by the square root of 2 on top and bottom, but I'm going to have you do that all underneath the radical. If we do 2 and 2 here, they're both under a single square root sign, and this is going to help us keep track of what goes where. So this 2 can be distributed to both parts, so that's 8 minus 2 square root of 7 over 8 times 2 is 16, all under one big square root symbol. So now at this point, we can go ahead and simplify square root of the top, square root of the bottom. And square root of 16 is a nice rational 4. Okay, so this is your final answer. Remember, we cannot take the square root of 8 and break it down when it's on top because there's a plus or minus here. Okay, it's not allowed. Alright, here's how it's going to really look on quizzes and tests. You have all of the parts together, A, B, and C are reviewed from last time. D and E are the half angles that we just talked about. Okay, so we're going to go in order and do this first one together. So starting out here, 180 to 270, we're still drawing it. Okay, we're doing that in quadrant 3, -2, 3, and we're using Pythagorean theorem to solve for this. So 3 squared is 9, -2 squared is 4, 9 minus 4 is 5. Square root of that could be positive or negative. We're using a negative. Show as much work as you need to here. Okay, 3 squared is the one that has to be by itself. Should not have written that first. Okay, so -2 squared plus x squared equals 3 squared. And then we're using that to find the missing piece. Okay, you didn't notice this, but I, on the last two, gave you sine every time, okay, because we were practicing with the half angles. Sometimes I'm going to give you cosine, so D and E right now you could actually do without drawing this picture. Okay, but they're all grouped together. I'm going to have you find the missing one first, because you do need it for part B. Okay, so our missing piece is sine. And that would be opposite over hypotenuse, negative square root of 5 over 3. Okay. Done with part A. Part B, we're using our double angle formula for sine. Okay, look at your note card for that. We've got 2 sine cosine. And we're just plugging in because we found all this stuff. Sine was that ratio we just talked about. And cosine was the ratio we were given. Okay, remember, if you can reduce ahead of time, please do. There's nothing that cross-cancels here. What I want you to practice for this one is talking about signs, because the biggest thing people mess up on this A through E are positive, negative signs. So here, we've got a positive, we've got a negative, and we've got a negative. When we multiply a positive times a negative times another negative, we get a positive. Then we can take care of numbers. 2 times 2 is 4. Square root of 5 to the side. On the bottom, 1 times 3 times 3 is 9. So our sine double angle is 4 square roots of 5 all over 9. Okay. Part C. Okay, with this one, we have cosine double angle, and there are options. Remember, there are 3 formulas on your note card, but you want to use the one that only uses cosine because that's what we were given. So that's 2 cosine squared minus 1, and we're just filling in. Cosine is a rational number this time, which means this is calculator friendly. Okay, you can throw the whole thing into your calculator if you'd like. Okay, we'll get 4/9, this is 8/9 minus 9/9, so it should give us a negative 1/9. Alright, and now we're finally to the half angles. Okay, what I want you to do for the half angles is do all your work next to it. If you already went too far over here, you can put it wherever you have room, but this is how I like it set up. Because what we're going to do on these two is automatically start with our lines being the half angles. And we are on this line going to decide the sign first. Okay, because that's what folks mess up with here, is we're given this, but remember that's the full angle. We don't care about this quadrant anymore. I care about where the half angle is. So we're going to take our 180 divided by 2, our theta divided by 2, giving us a half angle, and our 270 over 2. So that's 90 and 135 again. That is quadrant 2. And signs in quadrant 2 go left and up. So cosine gets a negative sign, sine gets a positive sign. And then we don't have to worry about signs on our final answer as we work through here. Okay? Going to your formula sheet, sign comes first. So that's our plus or minus. We just decided positive. 1/2, 1 minus the cosine of alpha. And we're plugging stuff in. So 1/2 stays. We're subtracting the cosine ratio. Cosine was given to us on this one. So minus a negative 2/3. Double negative adds together. Again, there's not a square root in here, so you are welcome to add in your calculator if you want to. Okay, I can take 3/3 plus 2/3 and get 5/3 and times it by a half faster than I can put it in my calculator. Okay, but if that is not true for you, you are throwing the whole thing in and putting the square root on top. Okay? From there, square root of the top, square root of the bottom. We have no perfect squares, nothing that breaks down, so we are rationalizing. So square root of 30 over 6. Next one looks similar. In fact, the only thing that's different about the formula is the sign out front, which we decided was negative, and the sign in the middle. Okay, sign in the middle for this one, it says 1/2. Sorry, my pen's dying, so I got some scribbles here. We've got 1/2, and this time it's going to say 1 plus cosine alpha. So we're doing a 1/2, we're doing a 1 plus, and it's still a negative ratio, so negative 2/3. Okay, again, you can throw the whole thing in your calculator. Okay, I'll give you a minute to do that. And this right here, 3/3 minus 2/3 is a third. Half of that is a 6. Square root of the top is 1. Square root of the bottom stays, and then we rationalize. So negative square root of 6 all over 6. Alright? When we've got one term instead of something plus something, like when it's irrational inside, okay, you rationalize the old school way. 6 does not have a perfect square that goes into it, does not break down, so you can use the number over itself. We didn't have to worry about this like we did the square root of 8. Okay, so what I want you to do on the last 3 problems, 8, 9, and 10, it's all review of things we've done. Okay, I want you to pause the video and try all 3 problems. If you get stuck on D and E, don't worry, do all you can, but keep going on to 9 and 10, and then we'll check them here and I'll talk you through the ones that are tricky. Alright. Here, I want to talk about D because it's messy. The other ones, just look right here for me. If you had a negative 6 over 16, you forgot to reduce. Make sure you're reducing. I cross cancel as I go, but if you're multiplying straight across, be sure you reduce at the very end. Okay, C was calculator friendly, so I'm not worried about that. Let's talk about D. With our formula on the outside, remember we care about the half angle. When you divide those by 2, you're in quadrant 2. Sign should go on the line first. Okay? Then our formula says we're subtracting the ratio we got in part A, the square root of 7 over 4, and we need a common denominator. So we're changing that to 4 over 4 and putting them together. Okay, the next step, when we multiply straight across, we have 8 on the bottom, which is not a perfect square, which means we have to rationalize. This is like the one we talked about on the front page. The square root of 8 on the bottom would have broken down to 2 square root of 2. Okay, because of that, we can't just use itself. We got to use that square root of 2. And we're doing that underneath the big radical. So this really does say the square root of 2 over the square root of 2. We're just doing it underneath so we know exactly where those numbers go. So the 2 goes times the 4, and the 2 goes times the square root of 7. Okay, looking like this. We're not going to simplify here. Okay, we're not simplifying because we did that 2 on purpose. We did it to get that perfect square on the bottom. So the 4 comes out. Bottom part, remember the square root of 8 cannot break down because it is on the top with something else. You have to subtract first. It's not allowed. Now what I want to do on part E, we have to work hard on these problems when cosine is an irrational number. We do not have to work hard for both of them though. Because here's the thing, if you compare the first step on D to the first step on E, the only differences are the signs out front that we already worked hard for, and the signs in the middle that come from the formula. If that's the only difference, y'all, the answer is going to look identical with these irrational ones other than those signs. You can just flip them. This only works when cosine is irrational. Okay, on that last problem we were doing, when cosine was a rational number, these did not look like positive and negative the same thing. Okay, because when you have a positive versus a negative here, you can actually combine those, where we couldn't on this one. Okay, so hopefully that helps with those. Last couple problems were review. The first one, I hope you recognize. Step 1, you can't draw this, but step 2, you can split it up to a sum or difference formula. Okay, remember, we have to go in order there. If you would have tried to do this with a half angle, it's possible, it's just messier. Okay, it would have looked like alpha is 390. So cosine of 390 is square root of 3 over 2. So we would have had this big ugly mess, square root, okay, because sine 195 is negative, then our 1/2, 1 minus square root of 3 over 2, and then we can put some stuff together here. This 2 goes up, 4 becomes 2. Would have looked like this. These are equivalent mathematically. If I type this in, remember you could always check these. Square root of 2 minus the square root of 6, enter, divided by 4. That's the same thing as sine 195. Okay, they check. But also, this is the same. So negative big square root 2 minus another square root of 3, enter, divided by 2. They match. It's just messier. Okay, so please don't forget sum or difference formulas. Okay, on number 10 you had to do that. Okay, so remember this number tells us our signs. Okay, this is in quadrant 2. Cosine is negative in quadrant 2. Okay, we're using the negative part of that ordered pair. And then we need alpha for the formula. So we just times that by 2. And then take the cosine. You can throw it in your calculator if you want. Filling it in. Getting a common denominator, calling that 2 over 2. And then multiplying that 2 through. Okay, this one has a 4 on the bottom. It's a square root that comes out nicely without us having to rationalize. Okay, homework gives you plenty of practice problems. If you struggle on anything with these half-angle formulas or with determining signs, please come see me.